All right, friends, we've made it. This is the last question that we're going to look at. Again, this is question number 6 from the 2016 AB International Exam. This question does not allow you to use the calculator, so resist the temptation. Put that calculator away. Here we go. A hive contains 3,500 bees at time t equals 0. During the time interval 0 less than or equal to t less than or equal to 4 hours, bees enter the hive at a rate modeled by E of t equals 16t minus 3t squared, where E of t is measured in hundreds of bees per hour. E is being measured in hundreds of bees per hour. Let's make note of that. During the same time interval, bees leave the hive at a rate modeled by L of t equals -2 plus 15, where L of t is also measured in hundreds of bees per hour. So a couple of things here. We have 3,500 bees at time t equals 0. We have bees entering, so bees enter the hive at this rate, but then bees are leaving the hive at this rate over here. This is one of those in and out questions, right? So you've got your hive. I'm not an artist, I'm a math teacher, but let's say here's my hive. And at t equals 0, we've got 3,500 bees. We have this function E of t that tells me how fast bees are entering, and then another function L of t that tells me how fast bees are leaving. And both of these are being measured in hundreds of bees per hour. Okay, we've got an initial number of bees in the hive. We have bees entering, we have bees leaving. Let's look at part A. How many bees leave the hive during the time interval 0 to 2? I just want to know the ones that leave the hive. Well, I have a rate function for L of t. So how many have left? That's going to be the integral from 0 to 2 of L of t dt. So that's the integral from 0 to 2 of -2t plus 15 dt. Remember, this is a calculator inactive question, so you're going to have to do the work yourself. The integral of -2t is -t squared, plus the integral of 15 is 15t. We need to evaluate from 0 to 2. So we do big parentheses minus big parentheses, -2 squared plus 15 times 2 minus the negative of 0 squared plus 15 times 0. Let's simplify this a little bit more. That's -4 plus 30. All that is 0. -4 plus 30 is 26. Now let's be careful. That 26 is what you got from integrating L of t, which is the rate that bees are leaving in hundreds of bees per hour. So what does this mean? This means that 2,600 bees, not 26 bees, 2,600 bees leave the hive on the interval 0 less than or equal to t less than or equal to 2. College Board awarded 1 point for knowing to find the integral. So maybe you wrote it this way, or maybe you wrote it this way. Either way, that got you the first point. Finding the antiderivative, that's this part here. Second point. Evaluating would normally get you a point, but what they said is it's this part here, your answer, which has to include the mention of the 100 bees, is where they awarded the last point. And so there's your 3 points for part A. Not bad. Let's keep going. In part B, part B, this is the one that tripped up all the students. So I want to make sure I explain this one well. In part B, write an integral expression involving one or more integrals for the total number of bees in hundreds in the hive at time t for 0 less than or equal to t less than or equal to 4. Then find the total number of bees in the hive at time t equals 4. So I need to write an expression involving one or more integrals for the total number of bees in the hive at time t for 0 less than or equal to t less than or equal to 4. And here's where students went wrong. What we're looking for is an integral that will work for any value of t from 0 to 4. Not at a specific value, but at any value. Well, how many bees are going to be there? It's your initial condition of 35 plus the integral of e of t dt from 0 to t, where t is between 0 and 4, minus the integral from 0 to t of L of t dt. It's the 3,500 bees in the beginning, plus the total number of bees that will enter from 0 to time t in hundreds, minus the number that are going to leave from 0 to t, also in hundreds. That's a great answer. Now, I'm really picky with my calculus students, and what I tell them is if you're using t, or if you're using a variable for your limit of integration, you should not use the same variable in the integrand. So a better answer is going to look like 35 plus the integral from 0 to t, e of some other variable, e of x dx, minus the integral from 0 to t of L of x dx. That's great. Now, at time t equals 4, now this is a specific time. It's the integral from 0 to 4 of your function e. And what's e? E is 16t minus 3t squared minus the integral from 0 to 4 of negative 2t plus 15 dt. Okay, let's do the calculus here. I need to integrate 16t minus 3t squared, that's 8t squared, minus t cubed, evaluate from 0 to 4, minus the integral here, negative t squared plus 15t, from 0 to 4. We're going to evaluate now, so big parentheses minus big parentheses, plug in the 4, 8 times 4 squared, minus 4 cubed, minus 8 times 0 squared, minus 0 cubed, minus, now I want to be really careful here, so I'm going to use brackets, big parentheses minus big parentheses, negative of 4 squared plus 15 times 4 minus the negative of 0 squared plus 15 times 0. And there is no way I am going to simplify this on the calculator inactive part of the test. What I will do though is add on the tag that whatever this number is, that's hundreds of bees. All right, so where did we get points here? 1 point for expressing your expression with the integrals, either this way or this way, got you a point. Finding the antiderivative of both this piece and this piece got you a point. And then your final answer is worth the 3rd point for a grand total of 3 points. Now, for any of you that were foolish enough to simplify this expression here, if you do this correctly, you're going to get 5,500 bees. I cannot encourage you enough. Just leave it. Don't simplify. It's a waste of your time. Okay, one more part. Let's see what we can do. All right. Part C. We need to find the minimum number of bees in the hive on the time interval 0 to 4. Okay. We've seen this before. That word minimum means absolute minimum. Okay? The way that we go about finding an absolute minimum, we first look for our candidate. The candidate is going to be the relative minimum. Okay? So this is where the number of bees is going to change. Now, if we're looking for a minimum, it's going to be where the number of bees changes from decreasing to increasing. That's the candidate. That's what we're going to be looking for. Then we look at our endpoints. And our endpoints for this particular problem are at t equals 0 and t equals 4. For both of these, we need to figure out how many bees are in the hive at time 0, how many bees are in the hive at time 4, and how many bees are in the hive at our candidate. Well, let's do it. To find where the number of bees changes from decreasing to increasing, what I'm going to do is I'm going to remember that E and L are our rate functions. So if I look at E of t minus L of t, the rate that they're entering minus the rate that they're leaving, I want to see where this changes from negative to positive. Because where the difference in these rates changes from negative to positive, that'll mean that the number of bees changes from decreasing to increasing. Well, what's E? E is 16t minus 3t squared. L of t is negative 2t plus 15. If I clean this up a little bit, 16t minus 3t squared minus a negative, that's going to be plus 2t minus 15. Combine like terms, negative 3t squared plus 18t minus 15. Well, if I want to know where this polynomial changes from negative to positive, the easiest way to do that is first figure out where your roots are. So I'm going to have to do some factoring here. If I factor out the common factor of negative 3, I get t squared minus 6t plus 5. Factor this further, and you can factor as t minus 1 times t minus 5. That means your roots are at t equals 1 and t equals 5. So what's going on here? You have two different values of t that are going to make E of t minus L of t equal to 0. We want to keep in mind that we're only looking on the time interval 0 to 4, so t equals 5 is not the candidate. T equals 1 is the only candidate. Now what I need to know for each of these t values the number of bees. We're going to look at the number of bees at time 0, the number of bees at time 4, and the number of bees at time 1. Well, how many bees at time 0? 3,500 bees. That's our initial condition. How many bees at time 4? 5,500. If you're thinking, where the heck did that just come from? That's the work that we did in part B. Now, how about the number of bees at time 1? Well, at time 1, we're going to have to do the integrating. That's going to be 35 plus your integral of E of t, 16t minus 3t squared from 0 to 1, minus the integral of negative 2t plus 15 from 0 to 1. Yes, we're going to have to do the work here. So this is 35 plus, well, we've already integrated this. We know that's 8t squared minus t cubed from 0 to 1 minus negative t squared plus 15t from 0 to 1. So that's 35 plus 8 times 1 squared is 8, minus 1 cubed, minus, plug in the 0, 8 times 0 squared minus 0 cubed is 0, minus, big parentheses again, negative 1 squared plus 15, minus, plug in the 0, all that's 0. Sorry for the bad planning there. Let's finish this off. 35 plus 8 minus 1 is 7, minus 0. Negative 1 plus 15 is 14. I'm subtracting off that 14. We get 42 minus 14, 28. 2,800 bees. The question that we were trying to answer was, just want to make sure we get this right, find the minimum number of bees in the hive. So answer the question. The minimum number of bees is 2,800. Oh, my bad. You see what I did there? 2,800 or 2,800, but not 2,800, 100, which was the mistake I was making over there. I should know better. All right, so where did the points come from? This was a whole lot of work, and I got to tell you, not many of my students were earning points here. This is part C. It's question number 6. It's the end of the test. You've got all of this analysis to do. They awarded 1 point when you realize that you need to set E of t minus L of t equal to 0. Some of my kids did that. 1 point for coming up with the answer, and I think the answer that they mean is t equals 1, but I could be wrong. They're not that specific here. And then, oh, no, never mind. This is the answer. The minimum number of bees is 2,800. And then 1 point, so no point there. 1 point for the analysis. That's the data table where you looked at the number of bees at time 0, at time 4, and at time 1. That was the 3rd point. So one more question worth 3 points. Tough question, but it was the very last question on the test. If you didn't get there, completely understand, but I'd make sure that this makes sense and that you would know how to do this if you had more time. Good job.